Okay, today we're talking about rational exponents. We're going to do a lot of exponent rules. This first section, 2.4, is just going to be converting between the radicals we've been seeing into exponents and vice versa. So when you have a radical, like right here, number 1, when you have a radical, whatever the index is will always be the denominator. Okay, so the denominator is the index. And then whatever is outside of the radical is going to be the numerator. So these are actually super easy to do when you're looking at given not a radical. So like this problem number 1 here. We look at what the index will be. So here, the index is going to be the denominator. So we get a 4. And then the number outside of the parentheses, the exponent outside, is going to be whatever the numerator was outside of the parentheses before. So the 4 is the index, and then the 5 goes outside the parentheses. And then whatever's in the parentheses just goes inside the radical. So that's it. So it's a little hard to see there, but it should look like this. 4th radical, 5x, parentheses, exponent of 5. So super easy to convert. Let's go the other way now. So whatever's in the radical is what goes in the parentheses. Whatever the index is the bottom of that fraction. And if there's no exponent on top, remember you have a placeholder 1. So that is 10b 1/6. So super easy. I want you to try it on your own. On problem number 3, this is going from the exponent to the radical form. So your answer should have a radical. Okay, inside the parentheses we get 3b. Our index is that 5, that was the denominator, and we have a parentheses 6. Okay, that is it for 2.4. It's just going to be going back and forth, back and forth. 2.5 is where we're going to use those old exponent rules that you used probably in, I think you learned them in 8th grade. So if you look, this is just all of the different rules listed. You won't use all of these steps every time, but whichever ones do pop up, just look back at the step to tell you what to do. So we're just going to talk through each of these really quick. Number 1, when you have exponents outside of a parentheses, remember to just do the exponent. So right here, that 4 goes to every term as long as it's all one single term. So x y 6 is a term, so we can distribute it. x4, y 24, we're multiplying. Exponent of 0, so number 2, remember anything to the power of 0 becomes a 1. The variable does not stay. So you pretty much just cross out whatever you see that and write a 1 instead. The next thing you want to check for is if you can combine any number coefficients. So if you have like a 2 times 2, or if you maybe have a fraction and you see a 2 over 4, that can simplify. So you want to check for that after you've simplified those 2 steps. So number 4, negative exponents will happen and you can't have them in your answer. So when you see it, the fun phrase I've heard is that if you have a negative exponent, it's unhappy and it needs to move to a different floor. So if it's in the numerator right now, like on number 4, it has to move to the denominator, and then it becomes happy and positive. So it will become positive every time you get rid of that negative as long as it switches places. And like we did here, if there's no fraction already made, you put a 1 over and it creates a fraction. If, let's say, there already is a fraction, like 1 over x to the negative 3, that would become x to the 3, what else was on the bottom. Okay, number 5, multiplying x's. So if you have the same base, so like y times y or x times x, you can add their exponents. You want to make sure you've already done the parentheses, though, if there are parentheses. Dividing, you're just subtracting the exponents, but it has to be the same variable. You can't do it with an x and a y. Okay, same variable. Number 7, you just check and see if there are any of those negative exponents after you've done this. because sometimes that subtracting will create one or the multiplying will create a negative. And then number 8, fraction exponents. So you probably haven't seen these fraction exponents before, so this is the new part of this unit. When you see a fraction exponent, when you're adding like terms and things, let's say you have a fraction 1/3 and another fraction 2/3, you still do the normal subtracting. They have to have the same denominator to subtract. So like this example, we'll get x, it's the negative 1/3 when you do 1/3 minus 2/3. This right here, again, you can't have the negative, but the other part you can't have is a fraction if it's in the denominator. So here it's fine because it's in the numerator. There's nothing under it. But in this example, see that 5/3? It's in the denominator, so we can't have it. So it's pretty simple to make it work. Make sure this is your very last step every time. But you'll basically round up. So that 5/3 rounding up to the next whole number is 2, because 5/3 is like 1.6. So if you round up to 2, that 2 is what stays on bottom, and it has to be a whole number. And then to go from that 5/3 to the 2, we had to round up by a third, and that third goes on top, right there. So that's where that came from. Your final answer can have 2 y's in it as long as you've already checked everything else and it's just rationalizing the fraction. Okay, let's just practice some of these rules. So problem number 1, go ahead and go through each of these steps. If there's any parentheses, I don't see any parentheses with exponents, go ahead and multiply those coefficients then. So we get 2 times 4 right here. So we get 8. And then we have 2 x's being multiplied, so x squared times x squared. We do add their coefficients. So we get 4. And then the y's, you look right here, y4 times y negative 5. So we add their coefficient, or their exponents. 4 plus negative 5 is a negative 1. So our final answer just can't have that negative. So it moves downstairs. It becomes positive, although you don't have to write the 1 because that's kind of a placeholder. Okay, go ahead and take a look at problem number 2. This one has that parentheses with an exponent, so that's the first step we have to do. So we're going to distribute this to every single term, including the 2 in the front. 2 negative 4, y negative 4. That y did not have an exponent before, but it gets one. X, so negative 2 times negative 4 is positive 8, times x to the 0 times negative 4 is still 0. 2/3 times negative 4, this one's a big one, negative 8 over 3. The bottom doesn't change when you're multiplying a whole number with a fraction. And then the bottom, because that parentheses includes the denominator, so we have 2 to the negative 4 and y to the 4. Okay, go ahead and look at your steps. Some of them you can kind of do in a different order if you like. For this one, I'm going to go ahead and I'm going to combine any coefficients that are the same. So this 2 to the negative 4 and 2 to the negative 4, those cancel because they're the exact same with the exact same exponent. We can get rid of this x to the 0 and put a placeholder 1 if we need, because anything to the power of 0 is 1. And then I'm going to go ahead and start adding things that have the same base. So like we have y here, and y here. So I'm going to go ahead and just simplify the top for now. Y to the negative 4 times y to the negative 8/3. When we add those together, we are going to want to change that negative 4 to have a fraction that can add with the negative 8/3. So negative 4 is also negative 12 over 3 if we want the same denominator. When we add it with the negative 8/3, we get negative 20/3. And then we still have that x to the power of 8. So this is going to be kind of a lot of room if you didn't write small. Okay, now I'm going to look at, again, those two y's that are left. And remember, this time we subtract the exponents. So when you subtract exponents, negative 20, remember we have to change this to 12/3 so that they have the same denominator when you're subtracting. So negative 20/3, take away 12/3, it's going to be negative 32/3. Okay, so we have that and the x8, and there's nothing in the denominator. Negative fractions do need to move, so go ahead and make your fraction bar with that 32/3 on bottom. But remember, it becomes positive when you do this. And lastly, if you notice, we have this fraction in the denominator. So we have to rationalize it. So rounding up, 32/3 rounds up to 11. If you need your calculator for that, you can. And we had to add a third. So we're going to get y11 on bottom, and then we have that x8, and then that third we rounded up goes on top. And that is our final answer. Okay, go ahead and try problem number 3 on your own, and then there's a question to answer for that. Okay, for these ones, go ahead. There's no parentheses, so we can multiply those coefficients. And then anything that has the same base. So here we have an n and an n. So the m doesn't change for now, but the n's add. And we do have to make sure they're the same fraction. So 2, we can make an 8/4 so that they add together, because adding fractions does not change the denominator. And we just want to simplify this so we don't have that negative. So we get 12. The m moves to downstairs and becomes positive. And between these two fractions, one needs to move. We can't have a fraction in the denominator. So this guy right here is what we're going to deal with. So we're going to round up to m2. 3/2 is almost 2. And then we round it up by a half. So that goes on top, and then we still have everything else on top that was there before. And that is it.